Hey, what's up? This video is about our story. I realized that we don't really have a record of where we've been and where we came from. So I wanted to kind of create almost a historical record, if for nothing more than our own posterity's sake. But hopefully this can entertain you and you can kind of see where we come from and potentially where we're going. So let's go ahead and get into it. So if you don't know who I am, my name is David Reed, and I am the founder and CEO of Reed Precision Manufacturing Company. Reed Precision Channel was birthed out of a desire to kind of showcase some of the cool stuff that we get to do on a day-to-day basis. So hopefully you're getting some enjoyment out of the channel. But specifically when it comes to our history, for lack of better terms, I was in the Air Force for 8 years. And, of course, we're based out of the U.S., so U.S. Air Force. I was in for 8 years, and I actually got out of active duty in 2017. My dad owns a company called Cutting Edge Tooling. What they do is they go around to, like, all over the U.S., and sometimes Canada and Ireland, just a lot of cool places, and they align sawmill equipment. So a lot of times, like, lumber is barreling through these pieces of industrial equipment, right, that makes 2x4s and 2x6s and all that stuff. They are barreling down this piece of equipment just lightning fast, just one after the other. Well, eventually, if you know anything about mechanical principles, eventually things start to shift a little bit. And so if the chain that's bringing the log through the saws is a little skewed, it's going to cut skewed. And so the sawmill is going to see a lot of loss. A lot of the costs that a sawmill incurs is the raw material, the actual logs coming in is a big cost. So if they expect to get a certain number of board feet out of a log and they get, say, 20% less or 40% less than what they expect, that's a huge loss for the sawmill. So it's pretty important for sawmill equipment to be aligned. So my dad kind of came up with this method of using a laser, not like a laser pointer, right, but an actual like aircraft grade laser, aerospace grade laser. Like it's the same laser that like Boeing will grade aircraft wings with, and it'll get it, over 100 feet, it'll get it within a couple of thousandths of an inch, which is, depending on the thickness of the hair, an average human hair is about 5 thousandths thick. So, they're getting it perfect, as close as perfect as possible, to put it in a nutshell. So I'm in the Air Force for 8 years, right? All right, at that time it had been about 6 years. My dad, I'm thinking about re-enlisting. My dad's like, no, don't re-enlist. Come work for me. I'm like, well, the majority of his employees travel. And I really, I've got a young family and I'm not interested in traveling that much. So I told him I didn't want to travel. He said, well, some of it would be required, but anyhow, decided to go ahead and take the job, and my commander was kind enough to, about 6 months before I'd gotten out, I'd signed a piece of paper, it's an Air Force form for everything, right? So I'd gotten approval through my commander to work on the weekend, so I would go travel during the weekend and then come back to Barksdale Air Force Base in Louisiana, which is where I was stationed, and work during the week. Well, as a plumber, I didn't really know what I wanted to do with my life. I just, knew I didn't really want to be in active duty anymore. I didn't really see myself being a 20-year guy. So as I was getting out of the Air Force, I needed a place to live. Well, the house that I grew up in a subdivision in Arkansas, just right outside of Russellville, Arkansas, to be more specific, my dad lived there. That was the house that I grew up in, and he had bought a CNC machine to put in the garage. It's just like a Haas TM1 from like 1998. The thing was a CNC, but I mean, it might as well have been a Bridgeport. You know, you're getting covered in metal chips, no enclosure whatsoever. So that should tell you how, what time period the machine was made in. So my dad says, your mom and I are buying a new house just half a mile down the road from you. And the house that you grew up in with the CNC machine in there is vacant. It's going to be vacant. Why don't you, Rachel, and the kids come live in the house that you grew up in? So I thought that was a pretty sweet deal. My son and my daughter get to grow up in this, you know, kind of how my siblings and I did when we were growing up. So, like, you know what? I'm going for it. Still, at this point, I really didn't know what I was going to do for Dad. The idea was that I would be some sort of operations director of some type, but there's nothing really defined. And at this time, Cutting Edge Tooling did not own a building in Russellville. It was just, you know, kind of ran out of their house. So we moved in to the house in Arkansas. And I'm like, he had that machine in there since I was a kid. And I remember him, accepting a machining job, because he built Cutting Edge Tooling as a machine shop, not as an alignment company. But the alignment side of the business just took off and there was no machine shop. Like, I would get off the bus and immediately go to work in the garage running that CNC machine. And at the time, I absolutely hated it. I did not want anything to do with machining. I didn't want to even, not just not do it, I wanted everything to do but that, right? To me, machining was kind of that thing that my dad made me do that I didn't really want to do. So, coming out of the Air Force, I knew exactly what the machine was, exactly what its capabilities were, but I did not really know anything about programming. I surely didn't know anything about machining, like feeds and speeds or material properties, figuring out, what tool to use with what material. None of that stuff did I know. I was just coming out of the Air Force, not really knowing what I was going to do with my life. So Dad and I talked about, instead of like operations, that I would just kind of learn CNC programming. And then once I kind of had it down, he would hire somebody that was more experienced in the actual machining components, but maybe more of a traditional machinist. That's kind of what our thoughts were. So you have my G-code programming skills, and then you have this person's, general machining knowledge. And so we found that that's exactly what happened. I learned CNC machining, University of YouTube, so I'm a firm believer that you can teach yourself just about anything, because this dummy learned G-code programming with YouTube videos and then just trying it. I'd watch the YouTube video and be like, well, shoot, let me try that, and it worked or didn't. But we hired Robert Galla, our now general manager. He's still with us at the company, but he was a maintenance manager at this big company, 1,000 employees or something crazy like that. He was the maintenance manager over there. So every day for like 30 years, he would go to this big plant to go to work. And then so he leaves that plant to come work for my dad in my garage. And his wife, like, you're basically Heisenberg, aren't you? Like, you're cooking drugs. This isn't a real job, right? Fortunately, we proved that, obviously it was a real job and stuff. But that's kind of where we started. And then, so 6 months after we kind of paired up, Robert and I, with our experience bases, together we made one really solid CNC machinist. But anyway, we ended up buying a building that used to be a truck wash in Russellville, and converted it into a CNC shop. And we took that one machine that was in my garage and put it into the cavernous space that we still inhabit today. It was about 4,500 square feet, and it was like, hello, hello, hello. One little machine in this big old space. So that was pretty unique. So pretty shortly thereafter, we ended up buying a Haas VF6. And the thing you can see here in the video is massive, right? Compared to a Haas TM1, which you saw in the other picture, this thing was massive. With the bay door open, I had friends that drove past my shop on the main road in front, and they asked me if I had a camper, like a Winnebago or something. Like, that's how big this machine is. Like, I could put a water or an air mattress in there and sleep in it. So that was a big machine for me to then learn on. But we bought that because we needed a bigger machine to start doing a lot of these bigger sawmill jobs. So we'd have sawmill will need us to machine this 36-inch long plate. And so we would machine that in the big machine, which was too big for the TM1. Then we ended up doing more sawmill things like rolls. These you see in the picture of us actually machining a roll. They have a knurled pattern, but it's a really, really deep. It's like 125 thousandths deep. But as we grew and started doing work, not just in the sawmill world, or the sawmill industry, but also in the poultry industry, we started doing a lot of work for the poultry industry. And then there's a couple of companies that are like these big industrial manufacturers that needed shafts turned down with our CNC lathe. So after the VF6, we were pretty brand specific at the time. We ended up buying a Haas ST30Y. And we did that because we were quoting a lot of those types of rolls. Like, we were able to kind of like pinch hit by putting them in the VF6, but we actually needed some legit turning. So you can see in this video, we're actually turning the vertical front to back knurls. The sawmill world is weird. Like, a typical knurl is going to be diamond pattern, but in the sawmill world, it's square in a lot of rolls. So we needed a lathe to be able to turn all of that, and then we took that because of the capabilities of that Haas ST30Y. We couldn't do the horizontal or the side-to-side knurls, so we ended up taking that over to the VF6 and just machining side to side. So the sawmill world has been very good to us in what we've been able to accomplish with them, in the type of part that we can do. But as you can see, a lot of these parts are really big parts. And so it bit us multiple times as we're progressing and trying to grow and become a viable business within cutting edge tooling. We see, oh, well, I just scrapped that thing that had 4 pieces that were welded and assembled, and I just scrapped that. So there's $4,000 worth of parts that were scrapped. And then we still have to wait an additional 2 or 3 more weeks to get the parts cut out again at the water jet company, then pre-machine, then assemble and weld, then put them back on the machine. So one part at a time, while they were bigger parts, and the profitability was good when you didn't scrap. But the problem is when you scrap, which isn't that the story, right? The problem is when you scrap. So we ended up wanting to diversify a little bit. So we ended up in the poultry industry. So with a lot of the other type of industrial work that we were doing, like we were doing these hardened 4140 shafts that actually had like a 0.5 thousandth tolerance on them, or 4/10. And so we needed something that could really hog out a lot of material while being accurate. The Haas was great, especially doing fine Y-axis work, but I needed something that could just turn 2-axis, hog a lot of material at the same time, and at the same time be accurate. So we ended up exploring our options a little bit more, and we went away from Haas in this particular situation because we found a Way lathe. Now, if you're familiar with Haas and the difference between boxways versus linear rails, you know that a linear rail is going to be less rigid than a boxway machine. And I won't take the time to explain it. If you're curious about it, Google it. But the boxway machine is extremely more rigid, and we were hogging a lot of material off at once on these 4140 shafts. So we ended up buying this Doosan lathe because Haas does not have a boxway option. So I explain that because there's a lot of true Haas fans that don't buy anything other than, and that's the reason that we went with a Doosan, which was definitely the call to make. That job we just continually do, like that's a consistent job for us. So it made a whole lot of sense to not wear the machine out, not wear out as much tooling, and to be able to do it better and faster on the Doosan. So that now brings us to 4 pieces of equipment: the Haas DM-1, the Haas VF6, the Haas SD30Y, and then now the Doosan Puma 2600. So right around that time, we were still cutting edge tooling all the way up until this point. I was kind of keeping separate records, not for tax purposes, but I wanted to kind of record revenues that we were bringing in that were specific to machine shop, that weren't tied to the alignment side of cutting edge tooling. I wanted to know that what money that we were bringing in, and I also recorded costs for every job, which was a lot. It was a lot of record keeping, but it made a lot of sense to do that because I was trying to prove to myself and to my parents that the machine shop could stand on its own. Because my end game was to make a play for just the machine shop. The alignment side, they have well-established processes. My parents are still young, like they have no interest in retiring, but I'm ready to be my own business owner. So it didn't seem fair for me to try to be ambitious and try to push them out of their whole business. But it also wasn't fair for me with an entrepreneurship heart. And after having built a machine shop from the ground up for the last couple of years, it wasn't fair to me to kind of put a cap on me and say, no, you can't be your own business owner. So my goal was to prove that Reed Precision, before it became Reed Precision, was a viable business. So I ended up proving that. So in July of 2021, I went ahead and started Reed Precision Manufacturing Company. And then I guess you could, as you say, the rest is history. So that next year, we had a poultry company that makes poultry equipment. They snowed us under with work. We were all working overtime, like required overtime. And of course, with the skilled trade gap, there's no like people. I can't just go down to the local trade school and be like, rustle me up 4 machinists. I can't do that because that's not an option. We trained everybody that started with us, and we still do. You can't walk into my shop right now with a resume of 20 years experience in CNC and say, hey, I want a job. I'm not going to hire you. I need somebody who is young and impressionable, somebody that can come in with no bad habits, and I can say, this is how Reed Precision does this. So we exclusively hire, I'll say exclusively, almost exclusively hire hungry people. And they don't have to be young, but young in the trade, somebody totally green in the trade. We have an internship program with the local high schools. They come in and work summer jobs, and that helps us kind of weed out the goods and the bads. The point is, we train people. So at the time, I didn't have just a repository of people that I could go pull from because of how we train people and how we onboard new employees. So we were all working overtime. So I decided, this is our first year, 2022 was our first full year of actual business. being under our own power, away from cutting edge tooling, and we were going gangbusters on the production schedule. Like, it was busy. So I decided to kind of explore our options with what machine that we should get. Well, the poultry customer, it's like a vast majority, like over 90% of the parts that we were manufacturing for them were turned parts, so lathe parts. And we had the 2 lathes, and the Haas lathe was doing a great job, but it was like banking up work. The production schedule was just stacked for live tooling work. So we were using the Doosan when its production schedule was available, which was very few and far between, to just turn the 2-axis stuff, part it off, and get it over to one of the mills who had a little bit more schedule time, because we didn't have enough live tool time. So we ended up exploring the option of another lathe. And again, I wanted a Way Lathe. I wanted something that was dual spindle. So we explored Swiss turning machines. A lot of the parts were smaller profile, so we needed a smaller work envelope. So I looked at a Tornos sliding headstock Swiss lathe. And from what I gathered just from other owners of Swiss lathes, they are really meant for tens of thousands of parts. Now, we had hundreds and thousands, not hundreds of thousands, right? We had, each part number would be like a couple hundred of each, and sometimes they'd be like 1,000 or 2, but never more than 2,000 parts at one time. So I needed some, and apparently Swiss lathes are also a pain to set up on the job, a pain to switch jobs over. And if you're a Swiss owner, let me know that I'm wrong. You know, I mean, if I'm wrong, I'd love to know it, because we're still going to be buying new machines. Like, this isn't where this company ends, right? So we have a future. Anyway, I'd love to know. I'd love to hear your feedback. But we decided Nakamura, really, really solid brand. It's a Japanese brand, and they were coming out in the U.S. market that year with a brand new machine called an SC100X2. And it was a dual spindle lathe. And so here's a video of it. This is actually the machine running simultaneous Op 1 and Op 2, which is insane to me. But we decided to go ahead and purchase this SC100X2 from Nakamura, and it was very cool because we had actually bought the first one on a production floor in the US was in our shop of the specific model number. So we took a little bit of a risk, but it has paid off in dividends. The thing's a production machine. So we bought that machine, and then, so flash forward to last year, 2023, we ended up buying a Haas DM-2. So it's a 40 taper milling machine that lightning fast. The tool change is like mere 1 point something seconds. I forget what the actual number is, but it's lightning fast. You got your finger on the chicken switch. If you're accidentally on 100% rapid, you press a green button, and all of a sudden you're in the cut before you can ease it down, right? Anyway, it's insane. The machine is fast. So we've been able to use that in a production capacity quite a bit. So I'm going to end the video here shortly, because we kind of ended where the history stops. And then now we're getting into where we're going, kind of thing, like where we are and where we're going. In which I'll have other videos of where Reprecision is going, what the plans are, and then updates as we progress. But I will end with this thought, that the Reprecision channel isn't just showing off like our machines and what we can do and look how talented we are. But most people, when they hear the word machining, think something dirty, not like dirty, but actually grungy dirty. They think, oh, well, they have to stand up all day. They've got to lift 100-pound objects all day. They're in a dungeon type environment where it's not really well lit, and it's gross and it's greasy and it's yucky. There's metal chips on the floor. And I probably should do a shop tour in the near future to show that how opposite our shop is from that sentiment. But the purpose of the Reed Precision channel, again, isn't just showing off what we can do, but I want to change the paradigm of what people think machining is. And Titan, Gilroy, and Titans of CNC have done a really great job at the PR game when it comes to changing hearts and minds of like paradigm shifting what people think machining is. But one voice isn't enough. So that's what I want the Reed Precision channel to be, is another voice showcasing that machining as a trade is amazing, that a lot of us live in climate-controlled shops. A lot of us have almost brand new machines, or at least they start out that way, or they're really well-maintained machines, right? And really well-lit environments, and everything is just nice, not this dungeon that's thought of. Like, oh, sweetheart, you work in a place like that? I want it to be like, oh, dang, man, you work in a place like that? Dude, that's amazing. That's what I want, okay? And so that's what the purpose of the Reed Precision channel is, to have some shorts and some YouTube videos that are like, oh, wow, that's insane. That's how they make that thing, right? But so it should have good entertainment value, but it should also send that message, even if it's subliminal, that, oh my gosh, this is what machining is today. This is American manufacturing at its best, right? So anyway, I really appreciate you making it all the way to the end of this video. It's a real long one, and if you made it to the end of this video, you're a real trooper, and I applaud you. But anyway, thanks so much. And we've got some more content coming out. We're working on a schedule of posting as often as we possibly can, even if it's just a 15-second short YouTube short. So stay tuned for all this content that we've got coming out. And thanks for being a part of our journey.